Hello, students, and welcome back to class. What we're going to do in this video is continue working on our fractions. Why? Because practice makes perfect. Let's start by changing a mixed number into an improper fraction. Keep that denominator. Now multiply 9 times 5, then plus 2. 9 times 5 is 45, plus 2 is 47. Now change an improper fraction back into a mixed number. Again, we keep that denominator. And how many times does 7 divide into 18? 7 will divide into 18 2 times, but there's some left over. 2 times 7 is 14. 14 from 18 is 4. 18 sevenths is the same as 2 4 sevenths. Look who's joined us at the math table. It's Big Bruce. Bruce is 23 pounds of orange love. For numbers 3 and 4, we're to rewrite these fractions in simplest form, which basically means to reduce. I'm going to rewrite these fractions. Now, if you can do these problems in your head, that's great. All you do is write the problem down and put the answer right next to it. If it helps to rewrite it, that's good too. X to the third means x times itself 3 times. X to the second means x times itself twice. Let's deal with the 24 over 28 first. 24 and 28 are both divisible by 4. 24 divided by 4 is 6. 28 divided by 4 is 7. Now look at the x's. I see that there are 2 x's in the bottom and 3 x's in the top. These 2 x's in the bottom can perfectly cancel 2 x's in the top. The same number in the bottom cancel the same number in the top. But then there's an extra x in the top. That has to go in the top of my answer. Again, if you can go straight from here to here, do this in your head. If it helps to write it out, that's just fine. Here comes number 4. I'm going to rewrite the problem. There's a single m in the top, but there's m to the third power. That's m times m times m in the bottom. Let's deal with the numbers first. 25 ends in 5. 55 ends in 5. When numbers end in 5, they're divisible by 5. 25 divided by 5. 55 divided by 5. Now let's look at the m's. I see that there is 1 m in the top, 3 m's in the bottom. Let that 1 m in the top perfectly cancel 1 m in the bottom. Same number of m's in the top, canceling the same number of m's in the bottom. But there's 2 m's left over. Those 2 m's left over have to be included in the answer as m times m, or m squared. That's the way we want number 4 to look. In number 5, I have a multiplication problem, but I have a whole number mixed in. Let me write the problem this way. I want that to look like a fraction. It does. I want that to look like a fraction. It does. I want 5 to look like a fraction. I can make it look like a fraction by putting it over 1. 5 and 5 over 1 are the same value. Now, when I multiply fractions, I try to reduce first. But my reducing must be top numbers with bottom numbers, numerators with denominators. I'm not allowed to reduce 2 numerators. Don't reduce this 5 with this 5. Any numerator with any denominator. I can reduce this 15 with one of these 5s. I have to pick one. I'll pick this one. divide by 5, divide by 5. Any other tops and bottoms? Look at the 4 and the 6. Divide by 2, divide by 2. Divide by 2, divide by 2. Don't reduce these 3's. They're both in the bottom. You can only reduce when you have a numerator and a denominator. Let's multiply what we have left. In the top, 2 times 1 times 5 is 10. In the bottom, 3 times 3 times 1 is 9. Got it. When you work your homework problems, make sure you show me the reducing that you're doing. Now for problem 6, we know that division has an extra step. We copy the first fraction, we change division to multiplication, and take the reciprocal of the second fraction. 7 over 12 becomes 12 over 7. Now look for things that can reduce. Any numerator with any denominator. Well, 12 and 16 are both divisible by 4. Divide by 4, divide by 4. Now multiply the tops. 5 times 3 and 4 times 7. Got it. There's exactly the way to show your work on a division problem. All right, your turn. Go work some homework problems and then meet me back here.